Heinemann Higher, Chapter 9 on integration, mixed exercise 9R at the end. Question 2, there's 3 indefinite integrals to work out. Right, so let's just carry out that process of building it back up again. This one's ready to go, so it's just a case of add 1 to the power, add 1 to the power, -1, divide that by that power, divide by -1. 3 will go back up to the linear term x, and x squared, add 1 to the power goes up to 3, divide by that 3, and then there could have been some constant there originally which disappeared through the process of differentiation and left no trace, so plus c. Now, nothing wrong with that really is that -1, and maybe I'll put them into a slightly different order. I'll put the 2/3 x cubed first, mainly because it's positive, but also because it's got the highest power, minus 3x, minus 5, and I might as well pop that x underneath where it belongs and put that down as my final answer then. There it is. Part A. Then B. Do B here at the same time. Now the thing about B is, there's probably a misprint in the book here going by the answer at the back and the fact that I've got this 4 floating at the side beside the dx, where in fact it should be the whole lot. So I suspect that bracket was really meant to be there. And don't bother with this little small print at the side. That's just saying, strictly speaking, for this expression, x couldn't be 0. Otherwise you'd have something divided by 0, which wouldn't be allowed. Although at the same time, why not say the same here? Because there's an x to the -2, which in the same case can't be 0. Still, first thing would be get this into a suitable form, so we'll need to multiply through it by x squared. So when you're multiplying terms, you multiply the coefficients and then you sort out the powers. Well, that's just got a coefficient of 7. Dividing the terms, power 2 subtract power 4 is power -2, but of course it's the x that's got that, silly. 2 for the coefficient, x squared over x squared cancels out, that's just 2, and that's just x squared. There it is, ready to go. So add 1 to the power, back up to -1, divide by that power. 2, back up to a linear term. X squared, add 1 to the power goes up to 3, divide by that 3, and put back that constant that had disappeared without a trace. And the last thing is, I think I'll just put it back in the order of powers. I've got 4 upon 3 x cubed, plus the 2x, minus the 7, and I'll put that x back underneath, plus c for the integral. There we are. And maybe I can fit c. Here's c. Again, that's not going to be involved in your calculations here. That's another just a disclaimer saying that you can't, this square root here can't be negative and the denominator can't be 0. But before that's ready to go, I'll need to split it into 2 parts. So I've got 6 divided by the root x and x divided by the root x. Put that back then, so that's 6x on top, so it's got a negative power, square root, so it's power 1/2, minus power 1 take away power 1/2, makes power 1/2. Now it's ready to go, and I've got add 1 to the power, 1 on to -1/2 is positive 1/2. Then instead of doing divide by a fraction, it was okay dividing when it was divide by a whole number, like divide by 3, but instead of divide by a fraction to create a complex fraction, I'll multiply by the reciprocal. So instead of divide by 1/2, I'll put times 2 upon 1, minus, add 1 to the power, so that's 2 halves can add on to make it 3 upon 2, and instead of divide by 3 upon 2, it's neater to make it times 2 upon 3, plus c. And I'll just put that back, well that's negative, maybe I will leave it on this side. So I've got 2 6s are 12, x to the 1/2 means root x, minus 2/3 of. The 1/2 in the power means the square root, and the 3 means the power, and then plus c. Probably looks neater like that. There it is then. There are the 3 parts for question 2.